Hey lads, gather round, 'cause today we're diving into the world of Rust and getting chummy with the basics. I'm talking about primitives. These are the alpha types that Rust is built on, and trust me, they're pretty fab. So, let's boot up and get cracking. So, Rust's got these types, right? They're called primitive, 'cause they're part of the language's core, like, they come with the package. It's pretty cool 'cause on top of these basic ones, the standard library throws in a bunch more nifty types. They're like the building blocks for the fancier stuff. But yeah, those primitive ones are the real OGs of the Rust world. Bools have just two possible vibes, true and false. Now, if you're feeling adventurous and decide to cast a bool into an integer, true will rock up as a solid 1, and false will chill out as a 0. And get this, bool is like a Swiss Army knife. It's got a bunch of traits like bit and, bit or, not, and the rest, letting us do all sorts of clever Boolean shenanigans with and, or, and not. When it comes to if conditionals, they're proper picky. They only want a bool. And that macro assert, it's a real lifesaver in testing. It's like your mate who always tells it straight. It checks if what you're saying is true. Alright, let's gab about char in Rust. It's a bit of a character. This one represents a single Unicode scalar value. You pop one out with just a single tick, easy peasy. But here's the kicker. Rust's char isn't some tiny 1-byte wonder. Oh no, it's a full-on 4 bytes of data. So it's like way more expressive than chars in some other languages. Proper roomy for all those Unicode bits and bobs. Time for a speedy tour of Rust's numeric types, folks. We've got a whole smorgasbord here. Some assigned, others unsigned. We've got fixed and variable sizes. And let's not forget the classic duo, floating point and integer. Now these types are like a double act. They've got their category and their size. Take U16 for instance. It's an unsigned superstar with a whopping 16 bits. And if you add more bits, you can count up to mega huge numbers. When you jot down a number and there's nothing to hint at what type it should be, Rust's like, no worries, I got this, and figures it out for you. So, you know how loads of programming languages have ways to line up a bunch of stuff in order? Rust's got that too, with its array type. It's a proper neat, fixed size lineup of bits, all marching in order and all the same type. And the cool part? These arrays come out of the box not changing on you. They're immutable by default, handy for when you want your elements to stay put. Arrays in Rust, they're typed with this funky TN business. The T is like a placeholder for any type. We'll get into the nitty-gritty of generic types another time. And that N, it's not just any number, it's a compile time constant that tells you how long the array is. So you set it once, and Rust makes sure it stays that size. No more, no less. It's all sorted when you compile your code, keeping things nice and tidy. Alright, now let's break down slices. Imagine them as a sneak peek into an array or something, without having to duplicate the whole shebang. Say you've got a massive file and you just want to peek at one line. That's where a slice comes in handy. You don't make 'em from thin air. They hitch a ride on a variable that's already kicking about. They've got a fixed size, but you can choose to keep 'em set in stone or switch 'em up. Under the hood, a slice is just a pointer to where the party starts and how long it's going to last. Now it's time to talk about our pal String Slice, or as her buddies like to call her, Stir. She's like the OG of the string family, super basic but totally essential. And get this, she's got this thing called an unsized type. That means she's pretty flexible and doesn't lock in her size until the the program, gets going. Don't worry, we'll hang out more with Stir in a later chapter when we dive into strings and references. Stay tuned. Oi squad, time to peek at Rust tuples. Think of a tuple as a neat little package of different bits and bobs, all lined up in order. They're like a fixed-size crew, each with their own unique vibe. You can mix it up, chuck in an I-32 and a string slice together, no problem. It's like a party mix where everything's different, but it all just works. All right, don't zone out yet, because we've still got functions to chat about. So, you've got these things called plain function pointers, right? You snag them by casting super chill functions, or those nifty closures that don't get all clingy with an environment. Now these pointers, they're like ice cream. They come in different flavours. You've got your safe ones, which are like your classic vanilla. They only point to the safe functions. But then, you've got the wild card, the unsafe function pointers. These are like your double chocolate with sprinkles. They can point to both the safe and the risky unsafe functions. It's all about how much of a daredevil you want to be with your code. So this is it. Keep your code snappy and your bugs scarce. Cheers to you, lass. I'll unwrap you later in another rusty session.